Here we have an example, cosine squared theta equals 1/2. And it gets a little weird when the squared is there and people seem to kind of just, I feel like you guys go into panic mode before you really push yourself and persevere and follow through with it. So I'm going to go over this right now. This is applicable to really any trig equation that has squared in it as sort of like that last layer of a step before you solve, before you really figure out what theta is, okay? So what we're gonna do is I'm going to kind of do a couple sets of directions with you. You'll see on the screen below me, it says part A. We're gonna solve for the answers between 0 and 2 pi. I'm gonna rewrite that the way I usually type it out with interval notation. So 0 with the bracket included, and then 2 pi is with a parenthesis not included. They're coterminal angles, so we don't need both of them. And then part B, which is was our real objective for our recent homework, I did ask you guys to find all radian solutions, and that requires the use of plus 2 pi n, comma, where n is an element of the set of integers. So I will also go over what that means, even on this example, even though you didn't need all that on this example. So we're gonna go over a bunch of things on each one. Now, one thing I want you guys to remember about cosine squared theta is what that really means. It's really the cosine of theta in its own set of parentheses, and then the answer on the outside, once you would figure out cosine of theta, that gets squared. So these two things mean the same thing. I could kind of compare it as a little extra side example to say you had the square root of x. Some calculators don't have square root buttons. So instead of doing a square root, if that calculator has an exponent button, you could do x, it's really the same as x to the 1/2 power, okay? That comes in handy if, for example, you had a cube root and you had to find the cube root of something and your calculator maybe doesn't have a cube root button. Well, you take that number and you would raise it to the 1/3 power. If you needed the fifth root of 32, and you don't have a fifth root button on your calculator, okay? A lot of calculators have it, or you're just doing a problem that's very busy with exponents, then you could also think of that as 32 to the 1/5 power, okay? So these are other ways that we can write something that we've done. What about if I have x divided by 2? There's more than one way to write that. That's the same as x divided by 2. That's also the same thing as 1/2 of x. That's also the same as, I guess, x divided by 2. Careful, it's not a square root. It doesn't have a little hook, okay? So there's many ways to write any one thing. So cosine squared theta is the same as cosine of theta squared. When we write it out, we write it like this in handwritten. And what does it mean? This. But if you want to write it like that, you just have to write parentheses every time. It's kind of annoying because if you just put it with the square there, then you're squaring theta and not cosine theta. It's a mess. So now we're here. If we're trying to solve for theta, we got to peel away the layer. So I got to get rid of the square. Well, how do I get rid of a square? What do I have to do to both sides of my equation to get rid of a square? We need to. You could shout out, answer in the chat. If nobody wants to do it, that's okay. But to get rid of a square, we find the square root of both sides. So I'm going to write it out like this and like this. And I know you guys know that that's what you're supposed to do. Now, where does the confusion usually lie? A couple places. One spot is people do forget and get it wrong because they forget that when you are the person putting a square root on a problem, you're the one that's like, I need to do square root. I will do square root. That the square root will need all answers. So that means you need a plus minus out front. Very important. That's one thing. Now here, my square and my square root are inverse operations. We don't want to say opposite because that's positive, negative. Inverse operations, adios. So all I have left on the left is just plain cosine theta. Now here, how do you take the square root of a fraction? Square root of 4 over 9, for example. Well, another way to write it or think of it is square root of 4 over the square root of 9. Don't get panicked just because you have a fraction in front of you. So when you have the square root of a fraction, we're not going to panic. We're just going to be like, well, it's the square root of the top and it's the square root of the bottom. So what's the square root of 4/9? Square root of 4/9 is, not all at once, 2/3. Good. So square root of 4, square root of 9, right? That being said, what's the square root of 1? Don't get weird on it because it's a 1. Square root of 1 is, answer for me, thank you, Matt, in the chat, 1. But what's the square root of 2? What's the square root of 2? If you have an Apple computer, if you type on your keyboard Option V, that will make the square root symbol. If you type Option with the letter P, that will make the pi symbol. Just so you know, Option and 5 makes infinity symbol. What is the square root of 2? So Matt gives me this decimal. Maddie gave me the golden answer there. So everyone, if you see in the chat what Maddie wrote. So whenever you want to be precise, Matt's answer is rounded because a square root of a number that's not a perfect square is an irrational number. That means that it goes on and on forever. It never repeats and it never terminates. It's an ongoing decimal like pi, and you can't be precise. So how do we keep precision? You just leave it the way Maddie typed it. And what did Maddie type? Square root 2. That's it. So if I say, what's the square root of 2? Literally the square root of 2. But what do we all do? We overthink it and we're like, 2? 1? 4? Like we get weird, you know, don't get weird. Now we can't forget our plus minus. Bam, there it is. Lesson 1 from this course. Lesson 1 was simplifying radicals. What do I need to do to this answer? What is it called? You can answer out loud. You can answer in the chat. Maybe it's a 3-word phrase. RTD. Go ahead. Who's that? Matt? Matt, what is it?
Rationalize the denominator.
You're the best. How do we rationalize this denominator? We're going to multiply on top and on bottom, numerator and denominator, by what amount? Make sure I hear from you. So you get points. Good, Shawnee, root 2. So we're going to multiply top and bottom, root 2, root 2. Amazingness. So what is my next line? And again, some of you might really consolidate all this work into like one step. You know, it depends on you. So now I get plus minus root 2 over 2. So what are you trying to ask yourself right now? You want to know on the unit circle, where is the cosine of an angle or the x value on the unit circle? Where is it equal to positive square root 2 over 2? What angle? So theta equals blank and blank. I'll move those directions out of the way. And we want to know where on the unit circle, does the cosine of theta equal negative square root of 2 over 2? So I'm just going to put them side by side. And our goal is to solve for theta. So I'm going to get theta equals this, theta equals that. I'm just going to move that over a little so I have more room so I can write my answers, because I'm going to have 2 answers for this. I'm going to get 2 answers for this. I think what happens, I don't remember who asked me about this example, but I'm sure that they weren't the only person that had a question on it. Who was this one? Was this Maddie, Adara? I forget. Somebody.
It was mine.
That was Maddie, yeah. So I'm sure Maddie's not the only one, but Maddie, do you feel like you didn't realize that it would turn into root 2 over 2?
Yeah,
right.
I just got confused.
Exactly. And a lot of people get confused. I feel like they start thinking maybe, did you think at all, did you feel like your brain thought about 1/4?
I don't know. I just get confused when I see like stuff like that.
Yeah, you just shut down. Your brain's like, overload, no thanks. So most people, the reason they struggle on this is they Thank you for participating in the chat with that. Thank you, Jasmine. I feel like don't realize, it's like, I always talk about chess. Like you have to kind of be thinking a few steps ahead, and we don't really see that this is going to turn into square root of 2 over 2. So remember, what's the square root of 1/2? It's root 2 over 2. Again, what's the square root of 1/2? Root 2 over 2. Okay. So in the chat, Jasmine's sharing is caring. She's sharing some answers. She gave us pi over 4 and 7 pi over 4. And that's actually the answer to this part right over there. This is all part A. I'll highlight it to color coordinate. Part B, what angles, if you could go off of what Jasmine shared, what angles are going to be my answer for over here? Negative root 2 over 2. Go ahead. Mason, you want to share?
3 pi over 4 and 5 pi over 4.
Amazing. You guys are all the best. Perfect. And I mentioned before, your denominators should all really match each other when they are coming like all cosine of the same ratio. So, this should look pretty good. Now, these are all the answers to part A only, and that might be all you had to do. If this was, say, on the warm-up, then that might be all I needed from you was the answers between 0 and 2 pi, okay? If I ask the directions that were on, like say the homework, our most recent lesson, to do part B, okay, to do part B. And part B is asking us to find all our radian solutions. And Moreau's like, what the heck are you babbling about, you crazy lady, about 2 pi n? Well, B, all you do is you say to yourself, okay, yes, pi over 4 is an answer. 7 pi over 4, 3 pi over 4, and 5 pi over 4. If you want a little visual to remember where those are on the unit circle, the angles over 4 are the ones exactly in the middle of each quadrant. So right here is 1 pi over 4. Right here is 3 pi over 4, 5 pi over 4, and 7 pi over 4. So the two lines that make an X, that and that, are what I just highlighted. Finding all the answers, though, is saying, but we could go around in a circle more than one time in a counterclockwise direction. I can spin around and make an angle clockwise, which would be a negative angle. I could flick a little spinner like on a board game, bloop, like this, and it's going to rapid fire, spin round and round and round, and I can get answers. I can get answers more than one time around the circle, So if you remember, I made this back in like September, okay? So back in September, I busted this guy out when we were first learning all this stuff. So sure, that's pi over 4. Cool, okay. But what if I went around, and landed there again? The cosine is still radical 2 over 2. I don't care how many times we spin around. If it overlaps or is coterminal to that spot, the cosine is radical 2 over 2. If it's overlapping or coterminal to this spot, I don't care how you got there. I don't care if you went around a billion times. I don't care if you went in the negative direction a billion times. The cosine is still negative radical 2 over 2. So I need to generalize or write a solution, and using 2 pi n is what helps us. I need to write an answer that basically says everything that lands here is an answer. Everything that lands here is an answer. So if pi over 4 I know lands here, how much am I adding by spinning it one time? How many radians did I just add to that angle? How many radians? Who can tell me? I need to know that you guys are present. So I need to hear from yous or see yous. So Moreau, what amount, if I went around one time in that direction, did I just add to that angle?
2 pi n?
Yeah, 2 pi. Well, just 2 pi for now. 2 pi is one full revolution. That's why the formula for circumference in geometry, back in geometry days, that's why the formula was 2 pi r. It was like saying a full circle times the radius, okay? So what I could do is I could say pi over 4 plus 2 pi, but I could add 2 pi one time, or I could add it 0 times. If I add it 0 times, it's just pi over 4. Or I could add it 3 times, 2 times. What if I wanted to subtract it, which is also adding it negative times? That's why we stick a little n next to it, but then we say in our answer somewhere that n is any integer. That little symbol I put though, that's really what that means, that n is any integer. And what are the integers? I'm just going to draw a little set notation, dot, dot, dot. Numbers like -2, -1, 0, 1, 2, dot, dot, dot. So it's like if I fill in a 2, right there, 2 times 2 pi is 4 pi. 4 pi is the same as 8 pi over 4, plus pi over 4 will give me 9 pi over 4. That's 1 pi over 4. If I keep counting, I'm just going to count the numerator. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, that wouldn't be 8 pi over 4 if I plugged in a 2, right? That would be, I'm silly. If I plugged in 2, that's 4 pi. That would be 16 pi over 4. Plus 1 pi over 4 is 17 pi over 4. So one time around, 9 pi over 4. Keep going. 10, 11, 12, 13, 14, 15, 16, 17 pi over 4. There's another one. So as you plug in different numbers for n, you'll get different angles that also land here. And we say it has to be an integer because it can't be a decimal. You can't do like half of a revolution because then it wouldn't land there. That's why we just say that it has to be an integer. Now I could do this. If you did this for every answer, you're fine. 7 pi over 4 plus 2 pi n. 3 pi over 4 plus 2 pi n. And 5 pi over 4. You didn't have, this was I think a do now question, so you didn't have to do this, but this is how you would do homework, okay? But who's going to be clever and help me right now? Is there a way that we could consolidate in this example? It doesn't always work. That I could consolidate all 4 of those answers into one equation. Take a second, think about it. Maybe you want to type it in the chat because you don't feel like talking. Maybe you think you could talk it out. Raise your hand. Maybe you think I'm speaking Greek right now and you want to tell me I'm confused. Then raise your hand and tell me you're confused. So this is what part B homework was. I'm just going to highlight this in pink and highlight the directions on the side in pink. Like I said, I'm trying to do a couple things at once. So if you go to finish that warm up after class, you have some help for that. And if you need to make homework corrections, you have some help for that. So anybody, can you think of, that's 1 pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Here's a clue. Think about how far apart those are from each other. Can you just start at pi over 4, and instead of adding 2 pi to every single answer, is there an amount you can add and get that answer, and then still add that and get the next answer? Add that same amount, get the next answer. And then you could just write one equation instead of 1, 2, 3, 4 equations. What amount, what could we add, or what could we do so that we just start at pi over 4 and get all of our answers at once? And remember, if you have a Mac computer, an Apple, if you hit Command, I'll call on you in a second. Command in the letter V, you make a square root. Command in the letter P, you make a pi. Command in the number 5, you make an infinity symbol. So those are some we might be using once in a while. So if you have a Mac, that'll be helpful for you. So let's see. Oh, I haven't heard from you yet today. Sydney, what are you thinking? What's going through your head for this?
Well, I see that they're all 2 pi over 4 apart.
Nice.
So I was thinking you could just add 2 pi over 4 for the equation.
And that's exactly perfect. So let me just squish this down quickly. Oops. Get that out of the way. I'm going to scooch this to the side for a little bit. So my consolidated answer, I'm taking all 4 of those. I'm going to consolidate. You could really pick any angle you want. If you like 3 pi over 4 best, then you can use that. But I'm just going to go pi over 4. I like to use my quadrant 1 answer if I have one. Pi over 4 plus, so she said, if this is pi over 4, that was 2 pi over 4, 3 pi over 4. So she knows it's 2 pi over 4 apart. And then you add another 2 pi over 4. And then you add another 2. As you add 2, 2, 2 all the way around, that's fine. So she could have written plus 2 pi over 4 n. And you could still do where n is an integer. This time I'll write it with the symbol. If you write it once on your homework on top of the page, that's good enough. But that is totally consolidated. or you could have reduced the 2 pi over 4 to pi over 2, but I do like leaving the common denominator. It helps you see it better, okay? I think someone raised their hand, or did you put it down? I heard the little bloop. Oh, no, it was in the chat. Okay. So that is a super consolidated answer, and that would be very clever if you did it that way. So what do we just go over here? This, I think, was on the do now. So if you didn't see it yet, or you didn't see it on your version, or you got it wrong, well, now we just went over it. So hopefully you get it right next time. We went over square rooting with trig. We went over what's the square root of a half. Memorize it, make your life easy, root 2 over 2. We went over part A directions, just between 0 and 2 pi. We went over part B directions. We want generalized solutions, which usually come in equation form. And then we also went over boosting up part B directions into a consolidated answer, which is a little, step up from just listing a whole bunch of different equations, okay? So this one here is just a little bit more sophisticated, more advanced and consolidated, okay? So I hope that that was helpful. If it was helpful, if you're watching this as a video and you want to give me an inventory, I've already seen a couple videos that have the thumbs down. I'm kind of prioritizing those types of examples. So I know you need more practice with that. And if everyone's got thumbs up on it, I know, you pretty much got that type. I don't have to go crazy, okay? So I hope that helps. So thumbs up, thumbs down appropriately. Do you get it? Do you not get it? Do you need more practice? Do you not need more practice? Okay?